Okay, we will have a real-time example of an object, and let us discuss how heat transfer is taking place and how to find out the amount of heat transfer. Okay, so what is heat transfer? How to detect heat transfer? What is the word? Q. Okay, when heat transfer takes place? Anybody can tell? Please cover them also. Okay. How heat transfer takes place? What about the temperature? Huh?
That should be temperature difference.
Very good. Tell me, stand up and tell me.
There should be a temperature difference.
Very good. There should be a temperature difference. When there is only temperature difference, a heat transfer takes place. Okay. Now let us have a small example. Okay. Here we are taking a plate. Okay. So this is a plate where the length is, okay, it is 6 meters. Okay. And the height is 4 meters. Okay. So this plate has a thickness of 0.3 meter thickness. So everything is given in meters. Okay. Now this is an plate. Okay. Now what happens is heat transfer takes place from this to this plate. So initially the temperature here may be, this is inner surface. This is inner surface. You can take it as TA. And this is outer surface, take it as TB. Okay. So this is the condition. Now what there is here, the temperature here, this is 100 degrees Celsius, and whereas at the outer surface the temperature is 40 degrees Celsius. Okay. So this is the condition given. Now what they are asking is, they are asking how much heat transfer is taking place in this condition. So this is the question. So this is the dimension of a plate, and they have given the temperature, the inner surface temperature and the outer surface temperature. They are asking to find how much heat transfer takes place through this plate. Already we have discussed that in a plate or in a rod, whenever it is heated, what happens? Heat is transferring. Okay. So the thermal conductivity K of this plate is given by 0.0 watt per meter Kelvin. So this is the conditions given. Okay. Now if you take, if the given, we can take briefly that here this length, okay, it is 6 meter. Here we take it as thickness. Okay, here it is 6 meter. And here this is 4 meter. Okay, now we have to measure first the area of this one. Okay, so here the area is 6 into 4, that is 24 meters. This is the area. Okay, so here what is the thickness here? 0.3. So now here we can take the thickness as 0. Now how to find out the heat transfer rate? Q. So here the formula is Q is del T by K into A. So this is the formula. This is the common formula to find out the heat transfer rate Q. So here what is del T is difference in temperature. Del T is nothing but difference in temperature, that is TA minus TB, or you can take T1 minus T2. T1 minus T2. So here T1 is temperature of the inner surface and T2 is temperature of the outer surface. So this is given in Celsius. So we have to convert into Kelvin. So here T1 is temperature of inner surface. Okay. So here it is 100 degrees Celsius plus 273. So we will get an answer. Same way here, T2 is same but outer surface. Okay, this is 40 degree Celsius plus 270. Now you can get the temperature T1, T2. If you substitute here, it is delta. Okay, and here what about Ka? So otherwise you can take this is L by Ka. You can take it as L by Ka. Length divided by thermal conductivity into area. Okay. What about L by Ka? What is the length? 6. Thermal conductivity 0.55. What is A? 24. Now please substitute and find out what is Q. Q is equal to del T by R. Here del T is given by L by Ka. Please find out what is the value. Okay, please make it.